If artificial intelligence is the destination, machine learning is the engine that gets us there. It's the technology behind most of what we call AI today, and understanding it, even at a conceptual level, will make you a more effective decision maker. So let's break it down in a way that's actually useful. Traditional software works on explicit rules. A programmer writes instructions. If the customer has been with us for more than 5 years and has spent over $10,000, offer them the platinum discount. The computer follows those rules exactly. It does what it's told. Machine learning flips this around. Instead of giving the computer rules, you give it examples, lots of examples, and the computer figures out the rules itself. Let me make this more tangible. Imagine you want to build a system that identifies fraudulent transactions. In traditional programming, you'd need to sit down and write out every rule. Transactions over a certain amount, transactions from new locations, transactions at unusual times, and so on. You need to think of every pattern a fraudster might use. With machine learning, you take a different approach. You gather thousands or millions of past transactions, some fraudulent, some legitimate. You feed them to a machine learning algorithm. The algorithm analyzes the patterns and learns to distinguish fraud from legitimate activity on its own. It might discover patterns you never would have thought to look for. The result is what we call a model, a mathematical representation of the patterns the algorithm discovered. Once trained, this model can look at new transactions it's never seen before and predict whether they're likely to be fraudulent. This is a fundamentally different way of solving problems. And it's powerful for a specific reason. It works for problems that are too complex or too subtle for humans to write rules for. Think about recognizing faces. You do it instantly, effortlessly. But try writing down the rules for how you do it. You can't. It's too complex, too intuitive. Machine learning can learn to recognize faces by studying millions of examples, just as you learned by seeing thousands of faces growing up. The same applies to understanding language, predicting customer behavior, diagnosing medical conditions from images, and countless other tasks that humans do intuitively but can't easily explain. Now here's what you need to understand as a leader. Machine learning isn't magic. It isn't free. It has specific requirements. First, it needs data, and not just any data. It needs relevant, representative, high-quality data. If you train a fraud detection model on data from only one region, it might fail when applied elsewhere. If your historical data reflects past biases, your model will learn from those biases. The saying in the field is, garbage in, garbage out. But it's more subtle than that. Even biased or incomplete data can produce models that seem to work until they don't. Second, it needs clear objectives. What exactly are you trying to predict or optimize? Machine learning systems are very good at optimizing for whatever target you give them, which means if you define the target poorly, you'll get results you don't want. A classic example: a system trained to maximize user engagement on a social platform might learn to show increasingly extreme content, because that's what keeps people scrolling. Third, it needs ongoing maintenance, unlike traditional software that does the same thing reliably forever. Machine learning models can degrade over time. Customer behavior changes. Market conditions shift. Fraudsters adapt. A model that worked brilliantly last year might be mediocre today. This is called model drift, and managing it is a real operational consideration. So when someone proposes a machine learning project to you, these are the questions to ask. What data do we have? And is it good enough? What exactly are we optimizing for? And are we sure that's the right target? And who will be responsible for monitoring and maintaining this over time? Understanding these fundamentals puts you ahead of most executives, who often approve AI projects without grasping what's actually required to make them succeed. In the next lecture, we'll go one step further and look at two main approaches to machine learning: supervised and unsupervised learning, and what each is good for.